right, ladies and gentlemen, today we're going to talk about a phase change chart. So this is basically what a phase change diagram looks like. So phase changes refer to when something changes state from a solid to a liquid, liquid to a gas, sublimates from a solid to a gas, so on and so forth. So looking at a phase change diagram, we're going to use a very simple substance. We're going to use water. Okay, so water has a freezing point of 0 degrees and a boiling point of 100 degrees. So let's say we are starting in a freezer that is at -10 degrees Celsius. If you take water or ice out of a freezer and you put it in a room that is at room temperature, that ice will begin to increase in temperature. The energy that it is taking is actually going to go towards changing the temperature of the ice, okay? Once you get to the melting point of the ice, at that point, you're going to switch gears and the ice is no longer going to be utilizing the temperature, the energy that it's taking in from the environment to change temperature. It's going to utilize that energy now to change state. So during that point, during this point, it is entirely a solid. And then here, it is changing from a solid to a liquid during the phase change, okay? Now, once it finishes changing state, it remains the same temperature. Once it finishes changing state, it now, as a liquid, it will continue to increase temperature until it reaches the temperature of the room. But let's say we're actually heating it to the point where it will boil. So now the energy will go back towards increasing the temperature of the liquid until it once again hits the threshold. Now this is the boiling point threshold. So here it will no longer, so it is a liquid here, it will no longer utilize the energy to change temperature. It is once again going to utilize the energy to change state, this time from a liquid to a gas. And then once it is a gas, it will continue to rise in temperature until it reaches the maximum temperature the environment or the system allows. Okay? Now, things increase or decrease temperature based on the direction of energy flow. For example, if I take something out of a freezer and I put it on a table, it is going to take energy from the environment because the environment is warmer than the item that was in the freezer, and it is going to increase in temperature, and it is going to follow the chart this way. But if you take the water, for example, and you put it in the freezer, it is actually going to give up its energy to the environment, so it is going to decrease. So the freezing point is the same as the melting point, and the boiling point is the same as the condensation point. It just depends on the direction of energy flow, okay? Cold is actually an absence of heat, and heat is energy, all right? So if heat is entering the system, it is going to increase in temperature. If heat is exiting the system, it is going to increase in temperature, or decrease in temperature, excuse me. Okay, so I hope that was helpful in regards to phase change. One way you can look at it, if you're driving a car, you get into your car, you start driving the car, and you increase. As time is increasing, you're increasing your distance, but then you get to a point where you blow a tire. So now, although time continues to pass, you're not changing distance at all, saying this is distance and this is time, because you got out of your car and you had to change your tire. So now that you've gotten out of your car, you've changed your tire, you've finished changing your tire, now you can focus your energy back on getting back in the car and driving to your destination. Okay? So if you think of it that way, your energy goes either to driving the car or changing the tire. You can't do both at the same time. Energy either goes to changing the temperature or changing the state. You can't do both at the same time. So either you're gaining energy or losing energy, and the energy loss causes either a change of state, in which case the temperature is stable, or it causes a change in temperature, in which the temperature is decreasing. And vice versa, a change of state where it in this case goes from a solid to a liquid, or a change in temperature where it increases in temperature if energy is being added. So hopefully this helped you out a little bit. If you have any questions, go ahead and shoot me a question and I'll be happy to answer. Have a fabulous evening.